Hello, Jason here, Kilo Zero Juliet Alpha Alpha, and I wanted to give a brief demonstration and description of the data logging software, Raspberry Pi, the modules, everything that I'm planning on putting in the balloon that we'll launch later this year during the eclipse. So first of all, I'll kind of run through the hardware side. First right here, this is the Raspberry Pi 0W, that's the Wi-Fi built-in version. It has a 64 gigabyte SD card that's attached to it that runs the software and should provide plenty of room for logging, acquiring pictures and video. Hopefully we'll be able to recover that later. This breadboard currently has the different sensors. First on the right is a BMP280 pressure and temperature sensor, and then connected to this right here, this probe is a DS18B20. It's just a really simple temperature probe. There's a RGB LED here that'll provide some feedback as far as what's currently happening in the script. A little button that will start and stop it. Eventually all of those components will be soldered onto this nice little board here to make a nice small package, and that just fits onto the pins of the Raspberry Pi. So I'll do that once everything has been tested. Connected to the USB of the Raspberry Pi is a very cheap and simple USB sound card. It's got a microphone in and a speaker out, and the speaker output is connected here to a Bofang that's set to Vox, and it's on 432.1 megahertz, so that'll transmit the data back to the ground on 70 centimeters so we can receive it and see what the current status is and hopefully record a log in case something happens to the Pi. All this will be powered by a little USB battery pack, and I'll plug that in and you'll see it starting a little bit later. So on the receive side, first just have a radio tuned to 432.1. That way we can hear when it beacons the packet. The computer, it'll be receiving using a USB RTL SDR dongle with just a simple antenna hooked up to it. And then on the software side, first right here we have SDR Sharp. That receives the signal from the dongle, and it outputs the audio from that through sort of a virtual cable in the software in the operating system. That audio is picked up by sound modem, and that'll actually decode the audio into from AFSK into AX.25 1200 baud packet. And below this I just have a simple terminal running, so it'll log the data. I couldn't figure out how to get sound modems to actually create a log, so that's just there for logging purposes. When it's running, you'll be able to see the data showing up both here, and you'll be able to see the actual peak right here when the data gets transmitted. Alright, so let's turn it on. Oh, forgot one thing is the camera. Attached to this ribbon right here, this is the Raspberry Pi camera. It's very small, nice little unit, if I can get it to focus on it there. This will actually take pictures and video, high def, that way we can see when we recover it later what it looked like from up there. I've got it pointing outside so we can see that video a little bit later. Okay, so I'll go ahead and plug this in. So there'll be a little LED that starts blinking on the Pi. It indicates it's powering on. And then when it's ready, the LED will turn white on the breadboard. That indicates the script is running and it's ready to start. Alright, so now the script is running. It is ready to start logging. We've got a white LED. Go ahead and press the button here, and that will turn the LED colors. The colors will change to green to indicate logging is started, blue is actually recording data, purple is when it's sending the transmit command, yellow is capturing picture or video, and then red means it's stopped. So we'll let it go through a couple cycles here. So there we heard a transmission, or we can see it. We can actually see the data. I've put sort of an identifier on the data, so every time it runs it has a different unique code, just to keep the logging separate. It just generates a random 4-character code. So this one, 0SGU will be the start of each one. 29.5 degrees centigrade, 29.7. Those are the two different temperature sensors. The pressure is 983.4, and it's registering this as 1 foot altitude. So when the script first starts running, it takes a baseline pressure measurement and basically sets that as 0. So every pressure measurement after that is relative to that 0 measurement. So we can see the relative pressure differences and calculate the altitude based on that. We'll let it run here and capture another packet or two. Alright, so it captured another one. The altitude's staying about the same. It says -1 foot now, so it'll vary a little bit. It could just be due to very small changes in the barometric pressure. Let's take another look at this when it's actually running so you can see the whole thing. Right now it's yellow, so it's logging data. I'm sorry, it's recording video. We'll let it run through 1 more minute worth of recording. Green is waiting, blue is recording data, purple is transmitting, green is waiting, yellow is taking a picture, it's waiting, and then yellow again is recording video. So that goes through one whole sequence. It's set to record 50 seconds worth of video and repeat it every 60 seconds. So it gives it 10 seconds to do the data acquisition and the data transmitting, and then it fits in 50 seconds worth of video. I've got it set to record a high-def video at 30 frames per second and take 1 photo at the highest resolution possible. Hopefully there's enough room. I'll have to do some calculations and see how much that'll take up on the SD card. But that should be it. I've also got some annotations on the actual photo and video that display the current altitude, temperature, pressure. That way we can see when we play it back kind of where it was, so we don't have to try to correlate those all to the data. One other thing I wanted to demonstrate was just stopping this. What will happen when we actually retrieve this, press the little button here, LED turns red, and it'll actually finish the current logging cycle, so you won't get an interrupted video or anything like that. It'll finish recording, and then there's actually not an indication there. It'll blink off for a second, I believe, as it ends the script, and then it will just stay red. So you'll know when it's red if you wait a minute. There we go. Now it's done, and it should come back. Now it is completely off, so logging is stopped at this point. So it would be safe to unplug this and get the SD card out and see what we've got. Alright, that is it. I'll do some additional testing and upload another video later. I also have picked up an accelerometer. I should mention too that I do have it set to beacon the same data 3 times. You might have noticed that on the actual thing here. Everything gets repeated. The purpose for that is just for possibility that we'll miss a packet, we won't pick up the whole thing. So we got 3 chances every time to record that data packet. So we can always go back and analyze that and see what we've missed and throw out the extras. Like I was saying, I picked up an accelerometer as well. I'm going to try to figure out how we can log that. I don't think once a minute would be very useful for an accelerometer because you'll miss a lot of the bumps, and especially when the balloon bursts. So I might try to do some kind of real-time monitoring and log peaks. But we'll go from there. Thanks for watching.